So this is PEL's jet deposition system. It's not inkjet, it uses a Piezo-Jet system. This particular one is from Nordson, and what you're looking at here is a graphene based ink. So this is an ink that has been formulated by PEL in Cambridge using the graphene from CGC. And it's been formulated into a jettable ink, so it's a viscosity which is a little bit low for screen printing but can be jetted. It's way too high for ink jetting, but it can be jetted with this jet deposition platform. So what this is, it's really quite a large nozzle on this particular head, but basically what you create is not a sphere but a kind of flying sausage through the air. So this is the drop flying through the air. It's around about 5 to 10 meters per second in this configuration, and it's relatively stable. It is a very viscous material, and so when it hits the substrate it acts a little bit more like a screen printing ink a lot more like a screen printing ink than an inkjet ink would do. And what I'll show you now is just a simple jetting test, and I'll put that on the end of the video. So the pattern we're going to run is a pretty simple hexagon pattern, as you can see here. I'm just going to hit start print, and that'll take the print head over to the print position. So this is an example of it printing with slightly more optimized parameters. It's not too much splashing. The print distance, as you can see, is a few millimeters. And there's still a little bit of splashing there, but the structure of the ink is more like a screen print ink. So it's quite a thick deposit going down. So these are the printed parts. As you can see, they're pretty thick, and as I mentioned, it's a screen print like ink, too low viscosity for really good screen printing, but okay for jetting on this platform that we have here. We also run it, that was in bitmap printing mode, as you could probably tell. We also run this in a vector based mode, which I can show now. So there's a little bit of splashing on that last one there, but that's probably because some of the parameters are not fully optimized for vector printing on this ink. But as you can see, so that's a graphene based ink using the CGC graphene in a jettable format, which isn't inkjet and isn't screen printing, so it may be relevant and may be useful for some of the partners on the project. So just to follow up on what the resistance of this jet printed graphene based material is, it's of the order of a kilo ohm per square, say. So we're looking at around sort of 900 ohms or so across that. And obviously when you don't have a square anymore, you've got a higher resistance, 1.5, what we got here, 1.5 here, similar. So basically the material's relatively uniform when it's jetted, as you'd expect, because the density of material going down is set by the number of drops per millimetre, which is fairly straightforward. And so it's a kind of a resistive rather than conductive layer, much like a lot of the stuff we've done in the Flagship so far. Anyhow, that kind of finishes off this jettable ink short video. Another test which is relevant to this type of ink is how well does it stand up to creasing, does it fracture? So, okay, and also we can measure the resistance. So let's measure the resistance here, and we're seeing 1.3K or so across the part. If I take that part here and I crease it, what you can see here is that there isn't a great deal of material coming off. So let's crease that again. This is a very aggressive test because this is a 125 125 micron PET. So the resistance here has gone up from whatever it was before to 2.1 K. So it is actually not a bad material, in that we can see here that the adhesion to the PET is pretty strong. Okay, there's a little bit of material comes off when you do such a crease like that, but actually it's not cracking off at all. So we're getting reasonably good adhesion to PET.